Welcome back as we continue to talk about these arithmetic sequences. So today we're going to move on to continue talking about them. However, we're going to talk about when we don't know all the terms at the beginning of the sequence. What if I give you two random terms of the sequence? Can you still find me the formula? And the answer is yes. Yes, you can. Now, again, note you are going to be given the explicit formula on your test, okay? You're going to have a sheet of paper that has this directly on it. All right, so that's going to be to your benefit. You just have to recognize when you need it. Now, the rule of thumb from this section through the rest is if you're ever missing a piece of information, something you need, always use the explicit formula to find that information, okay? What I mean by that is if we're given two terms of the sequence, okay, but if they're not in order, then we don't know what D is. And we need D in order to write the explicit formula, right? Because the explicit formula is written in terms of N, so we need A1 and we need D. We have A1, but we don't know D, and that's a problem. So what can we do about that? Well, there are certain things that I do know, okay? Again, I know A1. I know a future term, and I know what position that future term is. It's in the fifth position. So what you can do is use the information that you do know, because I know A1, I know a future term, and I know its position. If I use those three things, I can find D using the explicit formula. Okay? So first I'm going to use that formula to find D, then plug it back in to actually write the explicit formula properly in terms of N. So my future term, 18 equals my first term plus N minus 1. Well, in this example, we're talking about the fifth term, and right now I don't know what D is. So I'm using that explicit formula to plug in what I know because I need D. All right, so 18 equals 6 plus 5 minus 1 is 4. All right, well, subtract the 16, divide by 4. So in this case, my D is going to be 3. Okay, that's my common difference when I'm adding from term to term. So now that I have D, now I can properly write the explicit formula, okay? Because remember, the actual explicit formula is generic. AN equals the first term plus, remember, when you're actually writing it out, your variable is N. And your common difference you found to be 3. Let's write this nicer. Remember, whenever you're dealing with an explicit formula, you want to make it look like a line. So AN, 3N, 6 minus 3 gives me 3. So now I actually have my explicit formula written. All right? So again, I used the structure at first to find D. I plugged in what I knew to find D. Now I actually have the true explicit formula. And if I want A8, obviously at this point, I can just plug 8 in. So 24 plus 3 gives me 27. So that's going to be the structure to all of these. As if you're missing terms and you need the explicit formula, find D first, okay? Because you're not going to know D if you don't have subsequent terms. Go back, find the explicit formula, then you can plug in to find any term. So let's try this again. I know my first term, I know a future term, and I know the position of that future term. So I'm going to use that explicit structure, and in this case it's going to help me find D because I need D to actually write the explicit formula. So my future term equals A1 plus n minus 1. Well, in this case I know n to be 4, and what I'm looking for is D. All right, so 82 equals 100 plus 4 minus 1 gives me 3. Subtract that 100 over. So 82 minus 100 gives me negative 18 equals 3D. Divide by 3, and my D is going to be negative 6. Which makes sense because notice our number got smaller, so we should expect that we're going to be getting a negative D here, okay? That should be pretty obvious. Now, I need to erase this because I need some more work or some more space to work, but the important thing is now we know that D is negative 6. Because now that we know that D is negative 6, now we can actually write the proper explicit formula. So A1 plus n minus 1. Remember, when you're actually writing the explicit formula, n is your variable. Distribute that. So an equals 100 minus 6n plus 6. Remember, negative times a negative is positive. So really, we're talking about negative 6n plus 106. And if I want the 8th term, all I have to do is plug in 8. So negative 6 times 8 is negative 48 plus 106. My 8th term is going to be 58. All right, another way that they could present this same type of problem is something like this, where here's your A1, you're missing A2 and A3, and that is your A4. So sometimes if they structure it like this, I mean, it's the same idea, this exact same concept, but you just have to pick out that that is your 4th term. Okay, so now we do the same thing. We don't know what D is. So because I don't know what my D is, I'm going to plug in what I do know in order to find it. My future term equals the first term plus n minus 1. Well, in this case, my n is 4. And I'm looking for D. So 125 equals 80. 4 minus 1 gives me 3. So I subtract the 80 off. So 45 equals 3D. Divide by 3. I'm getting D to be 15. So remember, in order to write the explicit formula, that's going to be the first step. I need my D. So here, I found D to be 15. Now I need some more space. So now to write the actual explicit formula, 80 plus n minus 1, since I'm writing the actual formula this time, remember, n is my variable, and I found that in this instance, D is going to be 15. To distribute that, we're going to make this look nice. So 15n minus 15. So I get 15n, and then 80 minus 15 is going to be 65. So that is my explicit formula to represent this sequence. And if I want the 8th term, well, I just have to plug in 8. So 15 times 8 is going to give me 120, plus 65 is going to be 185. All right, they could also write it this way, where of course your first term is 2, my fifth term is negative 22. So there's always various ways that they can represent this and have you do this. But the goal is always the same. If you want to write the explicit formula, but you don't know D, plug in what you do know. I have a future term of negative 22, first term of 2. That negative 22 is my fifth term. So for now, my n is 5. And I'm going to use that to find D. Five minus 1 is 4. So subtract 2 and divide by 4. So my D is going to be negative 6. All right, so my D is negative 6. Now I need some more space. So now that I have D, now I have everything I need to write the true explicit formula. My first term plus n minus 1, remember for a true explicit formula, n is your variable, and my D is negative 6. Let's clean this up. So minus 6n plus 6, so negative 6n plus 8. That's my explicit formula. And if it wants the 8th term, just plug it in. So negative 6 times 8 is negative 48, plus 8 will give me a negative 40. All right, so again, that is the process of finding the explicit formula if you just know 2 random terms, which means you don't know D. Now, there is a little trick, all right? Something called the arithmetic mean. So if you know you're dealing with an arithmetic formula and you're only missing a term in between 2 other terms, then all you have to do is average the 2 numbers, and that'll give you that missing middle term, okay? So this is a nice shortcut that if you're just missing a term in between 2 other terms, use this method, okay? So for example, to find this missing term, I know I'm dealing with an arithmetic sequence. To find that missing term, all I have to do is average those 2 numbers. So 15 plus 59 is 74, divided by 2. Right away, I can tell you that missing number is 37. Over here, average these. So 14 plus 17 gives me 31, divided by 2. My missing term is 15.5. Or you could see something like this. The 9th and 11th terms of an arithmetic sequence are 132 and 98. Use the arithmetic mean to find the 10th term. So again, I have the 2 terms surrounding the 10th term. I have the 9th and the 11th. So all I have to do is average the 2 terms I have, and that'll give me that 10th term. When I average them, I get 115. Or what if you have something like this? So I'm looking for an unknown term, okay? This is telling me the term before it is 10. This is telling me the term after it is 16. So while that's a little bit confusing notation, remember, all it's doing is laying out the positions. My unknown, the term before my unknown, and the term after my unknown. So if I know that this is arithmetic, now all I have to do is average them. 10 plus 16 is 26, divided by 2 gives me 13. The arithmetic mean of the monthly salaries of two people is 4,475. One person earns 3,895 per month. What is the monthly salary of the other person? All right, so this time I know what the arithmetic mean is. Okay, I know one of the people earns that much, but I don't know the other person. So I'm plugging in everything to just that arithmetic mean formula. All right. And now I need to solve for that unknown. Well, to solve for the unknown, I'm going to multiply that 2 over. Okay, so I'm going to multiply both sides by 2 to give me 8,950 equals 3895 plus x. Now, obviously, I can subtract off that 3,895 to get that the other person is making $5,055. All right. So, lots of good stuff to build on yesterday. So, please make sure you write a summary for me. Discuss what we talked about today, what you're taking away from this notes, and then, of course, come back ready to work on your practice work.